Hello everyone. So before we move ahead, first of all I would like to introduce to some changes. First, I have changed the name of my channel to Algorithms Live. Earlier it was Think and Code and something like that. Now it's Algorithms Live, and yeah, the username has also been changed. Now I'll take you to the today's problem. So those who are new to this channel, here I'll be uploading daily problem solving videos. I try basically to upload the daily, and sometimes I might miss, but sometimes I manage the previous ones. Okay, so currently I'm resuming this session after 7 days because I went to a concert, and it's very difficult to actually solve seven of those in a live session. So I've decided to continue from today onwards. So those who are new to this channel, the format of the videos, the sessions is like this. So basically, first I will read the problem statement, then I will build an algorithm, and after that I'll match the constraints and check if that algorithm is well suited for the given constraints. If it is not, we look for further optimizations. So in algorithm section we start from brute force. Then we find the good solution which satisfies the constraint. We won't be going to the best solution because technically it is, or the time does not allow to do that, because it is an unseen attempt. It is an unseen attempt, because of which I'm not able to reach to the final solution in due time most of the cases, right? So without any further ado, let's jump to the iPad screen where I have taken screenshot of the problem and will be solving it. Feel free to drop your suggestions in the comment box. Let me refresh it to check if we are actually live. Yeah, I guess we are live. Without any further ado, let's jump. Correct, we are live. Right. So here we go. Cool. The problem says closest prime numbers in range, right? We will be given a range and we have to find closest prime numbers. Now what is closest? Let's check. Given two positive integers left and right, we have been given left and right. Find the two integers num1 and num2. We have to find num1 and num2, right? These two integers we have to find such that they lie within L to R, and L and R are closed, right? And num1 is lesser than num2, right? Both of these are prime numbers. Num2 minus num1 is the minimum amongst all other pairs satisfying the if conditions. So num2 minus num1 is minimum. Return the positive integer array. Okay, we have to return an array which contains num1 and num2. If there are multiple pairs satisfying these conditions, return the one with the smallest num1 value. If no such numbers exist, return if no such numbers exist, return -1 to 1. Okay, makes sense. So this problem is very much simple. Here we have to find two numbers in the range L to R, both closed, such that the difference between them is the least. So first thing first, what can we do? What can be the So the question is clear to all of us, right? We have to find the closest prime numbers which lie in the given range, right? Now let's check the example which we have. Left is 10 and right is 19. So what we got? 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19. Now which ones are primes? I'll circle them up, circle them out. So basically 11 is the one, 13 is the one, 17 and 19 the other two. Now obviously this is the closest one. So yeah, this got stored here. In fact, this is also the difference is 2 here, difference is 2 here, difference is 2 here. Now if we look for all the pairs, there is a downside because we don't need to. Why? If I look for 19 and 13, it is surely gonna be greater than 19 and 17. So we have to just look for adjacent terms. Make sense? Because in that case only it will be the least, right? So the basic idea, the first idea which comes to my mind is basically L and R will be given to us. We write L to R and we mark the spots where the numbers are prime. So if we spot a prime number over here, then we look for the next prime number which is here. Then we calculate the difference and store these guys in a set or something. We maintain a running variable, right? If we move to this point, we calculate the sum of these two. This point, then sum of difference of these two. Correct. So this seems clear to me. Now the range of L and R will define the complexity. So yeah, you can see L and R lies between 10 to the power 6. So we can easily go in this way, and this will be L, this will be R, and we can just mark the folks which are prime, and then just do this particular logic, this logic to get the answer. Right, so the marking stuff is also easier. It's not difficult. What we have to do is to, this is a prime number trick. This is a famous algorithm or something where what we do is this. So we have an array which has 1 till 1 to 10 to the power 6 elements, which is well inside the limit. And what we can do is basically here we have a visited set, or we have a marker set which marks if a particular number is prime or not. Make sense? So this will be a array only, which we can say like is prime n plus 1, which is 10 to the power 6 plus 1. So we start with 1, so 1 is not a prime, so 1 is an exception, right? Prime numbers start with 2 only, so we start with, ideally we start with 2. Initially we fill all of these to 0. Then what we do, step 2 is basically we start with a particular number over here, right? So let's say if it is 2, so what we will do here, we will mark this as prime, and whatever the multiples of 2 are there, like we go ahead and do 2 into 2, which is 4, which might be here. Then we have 2 into 3, which is 6. All of these deserve to be 0, right? Similarly for 3, similarly for 4, and likewise we go ahead and keep going ahead. Let's say if we got 14 in some point of time, we got 14, so we don't need to go for 14 into 2. If we got 14 again, then we don't need to go into 14 into 2 because we have already covered all the cases where 14 multiples of 2 are discussed. So that is good, right? So what we can do is we can further reduce this by removing the, what do you say it, removing the even elements. Even numbers can be just skipped, that's fine. Yeah, we can remove, we can skip the even folks from this part. Why not we do this? We initialize all of these to ones and make the zero, make them zero. Like we reach to them with in the multiples of the elements, right? Let's say if we are handling 2, so we handle all the multiples of 2 which are there in the particular array, right? And we just mark them off, and in the next step we go with 3 and we do the same to the 3. So what I was thinking, to remove all the even numbers at the first place, so we would go something like 1, 3 ones are 2 is there as a prime, 3 ones are 3 is a prime, 3 3 threes are 9, then 3 fives are 15, right? We can move in that direction, which will make it even easier to compute. We have assigned all the numbers to 1 initially, that means they are prime, and as we relax them out, they are going to be evens, right? Cool, so I got this. So what I'll do, so this is my algorithm, which will probably pass the cases which we have in the hand. So the algorithm is this: create a SP array which is initially set to 1 for odd and 0 for even. 1 means that it is prime, 0 means not prime. So we initially assume all the odds are primes. Now we'll start here. This was step 1. Step 2 is we go ahead and do this for all the 1 for odd and 0 for even, right? For all the odd numbers, we start with 3, then we go with 5, then we go with 7. Likewise, for all the odd numbers, we can move in the multiples of 2 if marked as initially all of them are 1 only. Okay. If marked at 1, then only process its multiples. So since 3 is 1 initially, so 3 into 1, 3 into 3. Here also you have a gap of 3 because gap of 2 because there are no evens involved, right? So if I do 3 into 2, it will be 6, which is even. So I removed them. So like that, 3 into 9, all the way up to when the range is less than 10 to the power 6. We go ahead and mark these multiples as 0. And if it is 0 marked already, like let's say we have 3 threes and 9, the multiples of 9 which will come further are already marked. Okay, so by this way we get the everything sorted. We get the this is p ready, and then step 3 is there where we maintain a previous and we maintain a next, which is initially -1 and it is initially -1. What we do, we have L and R. So we find the first one, first guy, prime guy as P, and then look for the next one. And report the answer at earliest. That can be done easily. Now, without any further ado, I would take you all to the screen where I solve the question, the Leetcode screen, right? So I'll try to solve this in one go. Let's see how well we are able to do it. First thing first, I start with mentioning the data structures needed for this. So which we need, definitely need that. So we have an n defined here, which is 1. Okay, so do we want to go like this? Yes, we want to go like this. We want to have a is prime number computed with us. By the way, it will go to till 10 to the power 6 only, so we are good here. So n is 1 e9. No, 1 is 6 plus 1 for the safety purpose. What we do is we define a is prime number, which is this. Cool. We assign it if I modulo 2. So 1 will be ideally 1 only. So if I modulo 2 is equals to 0, is P of I equals to 0. Is P of I becomes 1 because we assume them to be primes. This is done. Now we need to go to the next step, which is the computation step. This is called prime computation. So here we need to maintain. We'll start with 1 is actually a 1 is actually a even 1 is actually not a prime number. Is P of 1 equals to 0 and is P of 2 equals to 1 because it is a prime number. So we don't need to worry about multiples of 2 because they have been already taken care in this step. They cannot be prime. So we can simply start with 3. I is less than n, and here is the magic. Here we increment it by 2, right? And if is P of I is equal to 0, then we skip. If it was 1, we need to process the multiples of it. So we maintain a multiplier which initially is 3 because 3 is the next guy, while I multiplied with multiple is less than n. Then what we have to do is to HP of that I multiplied with m is equal to 1. Makes sense? Is equal to 0 because these are not primes anymore. And then we have to do this m plus equals to 2. This will compute the things which we need. Correct? After computation, we go to the next step, which is calculation. So we have integer, two numbers here, integer x and integer y, both of them are assigned to -1. Now we go in the loop, integer I equals to left, I is less than equals to right, I plus plus, right, I plus plus. If there is only one prime, then in that case, what can we do? If there is only one prime, in that case, what will be the difference? What will be the two pairs? Okay, if there is only one prime number, then we have to, yeah, return the, like we have to return whatever is the particular, we return the -1 basically. So we have an answer which is initially, the difference is initially equals to -1. So if we find, if x is equals to -1 and then y is equals to -1, and if we found that is prime of I is equal to 1, in that case means it is prime, right? Of 5 that we do. If it is not, if it is 0, in that case what we need to do, we got nothing. So first we need to set x, then we, if x is set, both of them are -1, if else x is set, then we need to check for y. If sp is equal to 1, means we have got a y. If sp of I minus x is greater, strictly greater than answer, then we have to do two things here. X is already set to that guy. We have to set our y to SPI. So basically these are running guys, right? But we need to store the answer guys. So we can do it like this. Answer x equals to -1, answer y equals to -1. So y should be set here, that's fine, but why can we can set y anytime, because this is the y's fate, because y has to be set, because if you got another number, y has to be set. After setting up y, what we can do here, do we really need to set y? We just need to update our x. Now if this number is greater than answer, then we have to do this, answer x is equals to x, answer y is equals to SPI, and answer itself is equals to SPI minus x. This will do the job. And yeah, we got this answer x and answer y, set it up. Now what we need next is basically we need to do this. If answer x is not equal to -1 and answer y is not equal to -1, in that case we have to return answer 1, answer x, answer y, else we have to return -1, -1. I hope this is the entire logic and we don't get any errors. Okay, we got some compilation error. What is the error here? Variable length arrays in C++ are Clang extension. Okay, so it is not const, right? So I can do like const int, then it can just work fine because it has to be non-variable. Alright, so okay, this is they are expecting it to be lambda function. Let me see this. So what I'm doing here is returning this array. Okay, so we cannot do it like this basically. Cool. So I create a vector answer or pushback answer x answer dot pushback answer y. So we return here answer. This will be good only, but here what we need to do is to we need to explicitly set answer 0 to -1, answer 1 to -1, which it might be case one of them is not good, right? So we return this. So there's an error here. Okay, basically answer has been used multiple times. So I call this solve, yeah, I think this is the final code and we are getting wrong answer in it. Let me see how. So the output which we are getting is 1 1, which is really surprising because we move from L to R, right? Okay, so this is actually my bad. Basically, this has to be X only. And this as well should be X. I don't think anywhere else we need some modification or something. This seems okay to me, or maybe here. So we do get 1 and 19. So we started from left. What was the left here? It was 10. If x and y are -1, and if this is 1, then we do x of x is equal to I. So 10 is anyways even, so it will be treated as 0. Else if one of them is -1 and if both of them are -1 means what? X and y, they are not set. So if new prime comes and one of them is set means x is set. So we check this. Otherwise we update our x to is pi. This is wrong. We update our x to current I. Let's go ahead and run it up. I think this will pass the solutions. Okay, so there's some issue. Okay, so I'm looking for the maximum guy, but I have to look for the minimum guy. So let's keep it n plus 5. I hope this will do the job because I is greater, right? Yeah, so it is now able to capture it. And yeah, it is able to capture it. Let's submit it up. Yeah, so it was able to solve the problem in one go, which is 60% complexity is beaten up, which is ideally order of n only. If I analyze the complexity, it is order n. Correct? So quick recap what we did here. First we decided the data structures which we need to maintain the prime numbers, and after maintaining the prime numbers in a best way, what we started doing is basically we choose that range and we just keep looking for the new values which we get, right? And then we assigned x and y depending on the shortest difference. So yeah, this is the today's problem, guys, and it is solved. I hope I'm visible. Yeah, so this is the case. Let me check if we are live or not. So yeah, this is the today's problem, guys, and it is solved. Yes, we are live, and now I'm feeling very sleepy. So that is it for today. We'll meet in the next one. Bye bye. Take care. Good night.